Single-threaded Qaud Core V.S hyperthreading dual core. Let's say we have two CPUs. One is quad-core 3.2 GHz with 4 cores, and we have a dual-core 3.2 GHz with 2 cores with 2 threads in each core, hyperthreading. My assumption as a programmer will be, the 4 cores 4 threads should perform faster than 2 cores 4 threads, since the second CPU needs to switch between threads in order to emulate 4 cores, while the first one doesn't need to perform such switching, as each core can perform independently and individually. I want to confirm that my assumption is true. If not, please explain why one is better than the other.
I do believe that's true. Since hyperthreading does share some elements, specifically the main execution resources, you'll be able to run 4 full threads at once, rather than waiting for those resources to be freed up. The point of HT is to get better performance with a smaller use of die area. Your quad core would generally be a bigger chip, say almost twice as large, than a non-HT dual-core chip, while a HT dual-core chip would be about 5% larger. The quad core could see up to twice the speed under the right workload, though unlikely, since you probably won't be running 4 threads at full capacity in most cases, while the dual-core HT processor would see 15 to 30% better performance, according to Wikipedia, than a dual-core non-HT processor. More actual cores is usually better.
From Wikipedia. Hyperthreading works by duplicating certain sections of the processor, those that store the architectural state, but not duplicating the main execution resources. This allows a hyperthreading processor to appear as the usual physical processor and an extra logical processor to the host operating system. HTT unaware operating system C2 physical processors, allowing the operating system to schedule 2 threads or processes simultaneously and appropriately, when execution resources would not be used by the current task in a processor without hyperthreading, and especially when the processor is stalled. A hyperthreading equipped processor can use those execution resources to execute another scheduled task. The processor may stall due to a cache miss, branch misprediction, or data dependency. If you have a quad-core system, then 4 threads can run each on a full core. If you have a dual-core hyperthreading system, then 2 threads could run each on a full core, but with 4 threads, the threads 1 and 2 will share one core and threads 3 and 4 will share the other core. Hyperthreading allows 2 threads to run in parallel, only if they do not use the same processor resources. So in an ideal case, you might get a high degree of parallelization, but as Wikipedia states, the performance gain is not 100% but only 15 to 30%.
In hyperthreading, the idle time of the core for tasker, the said core could have sent a request to the disk for data, wait for the disk to seek the area of the platters, read the data and send it back to the core, is exploited to perform another task. So, when task is being serviced by the so-called thread 2, and if data fetch request by tasker is completed, tasker still have to wait for the core to finish thread 2. Both threads cannot be executed simultaneously in one core. Again, HT exploits the speed mismatch between the core, processor, and the various subsystems in your computer. HT uses your cores to full capacity. It is like full capacity utilization. So, if you open 4 tabs in your browser, each tab will have a core in a 4-core system and 2 tabs will have to share a core in a 2-core system.
Ironcellid, easily glad